Hello, can you hear me? Hello. Hello. Good evening, everyone. So we'll start in few minutes. Can you hear me? Am I audible? Hello.
Yes, sir.
Okay. Okay. We'll start in some time. Please stay. Huh? Hello. Okay, once again, good evening, everyone. So, hopefully, I'm audible. So, we'll start with today's tutorial. I think it's already time to start. I was waiting for few minutes to others join. So, yeah, this is Rahuldev from ISA Tiruvananthapuram. I will be your teaching assistant and another teaching assistant who will be taking class on another day. So, this is first tutorial. I hope it is your first tutorial. And yeah, so if I'm not wrong, then this is the summary of the lectures. At least I mean, what are the things uh, Professor Joydeep that the taught are these, right? So in the lecture 1 to 5 you had these number systems like natural number, set of natural number, integers, rational numbers, real numbers, and irrational numbers, right? And you saw q is dense in r, you saw, and countability in you saw this, you can count set of natural numbers, you can count set of all integers, you can count set of all rational numbers, and set of all real numbers, and or is any interval or uncountable. And you saw also what the irrational numbers may look like, and you have seen functions, the definition of functions, domain, codomain, injective, surjective functions, and limit of functions you have seen, right? Can anyone just confirm it? All are okay for all of you? Yeah. This theory part is clear to all of you, right? I'll proceed with assuming that, or any doubt here? You know, right, how Z is countable? Sorry, let me. Z is countable, you know how to show that? Any set is countable, how to show that? Yeah. Yeah. Can you respond for someone that is message? Are these things okay to you? Like how to show that set of all integers is countable? How to show that one any set is countable? Like how you give the any map or something? Any correspondence with set of all natural numbers, right? If you have a bijection between set of all natural number and between the set S, then that set is countable, right? Okay, so how to show that Z is countable then? So what is the map which corresponds the natural number with uh, integers? Yes. So Z has like this type of elements, right? 0, plus minus 1, plus minus 2, and keep on going. You have natural number like this. Sorry. Oops. 1, 2, 3. Right? So how to construct a map which, let's say, take n belongs to a natural number, which will give you, like, let's say when n is odd number, means it is of 2k plus 1 form. So let me write like this. I will see whether it is working. Otherwise, n by 2 if n is even, right? So can you see this is the map which is a like one-to-one correspondence, one-one map. At least someone can tell whether it is one-one map and whether it is onto. So you check it, okay? So what you are doing here, you have when you have odd numbers, so that is going to first one is going to 0, and you have even numbers that is starting from 2 is going to 1, and you have three odd number that is going to okay. Yes, so okay, it's not n minus 1 by 2, it's a negative of n minus 1 by 2. Okay, so when 3, this 3 is going to 1, and if you take 4, 4 will be going to 2, and you have now 5, you take 5 will be 5 minus 1 by 2 means minus 2, 5 will go to minus 2. So it is, you see, and 6 will go to 3. So it is like it is going like this. So what are the odd numbers? It is corresponding to negative values, right? Negative natural numbers, and even values, even natural number, even natural number, even numbers are going to usual natural number. So and you have integers which are union of all those. So what you are getting, you can what by this, if you can show that this function is a one map and one to map, then this is will be z will be countable, right? So this is very easy to show whether map is one or on two. So this will be what this function will be, this function from n to z defined like this will be uh, one and on two. Okay, so that's how we can show that z is countable. And you saw, I think, why I was asking, so z it was not told in the class, but q, which was like much more difficult, so that was given, that idea was given, how to prove that q is countable, right? So these are the some basic things you need to know, and you need to know limit definitions, like epsilon delta definition, and yeah, all the injective subjective codomain range, then everything else are done. So these are number system, and these are the functions. It's a little bit the part one of the limit of the function, and yeah, that's all about this first lecture 1 to 5, so lecture for week 1, right? So now tell any other difficulty in the lectures or theoretical part. Otherwise, I will move to questions. Okay. So this I was just asking you question, and I thought this Z is countable or not. That I should just give uh, a simple way. Anyone have any doubt in the theoretical part? Okay. As someone said, they don't have any, like, at least he has no doubt. He's asking to move to the problems. So that's all I will do. So although I just written all the problems, we'll go one by one. Okay. First is, let's say whether square root 2 plus half is rational or irrational. Prove it. Everyone try. So okay, let's move to here and write the question. Square root 2 plus half, whether irrational or not, irrational or rational. How to prove that? Our usual way to prove that, you consider, if you think it will not be uh, irrational, you assume that it is uh, sorry. So if you want to prove that it is uh, not rational, you assume that it is rational and you prove by contradiction, right? So if anyone is messaging, instead you please speak, then it will be better. Okay. Okay, so I have to every time come to a different device to check your message. Okay, but if anyone else who can like tell others his message, then that will be also okay. Anyway, so but did you prove that exactly how to show that? Let's say square root 2 plus half is equal to A over B type form, where this GCD of AB is 1 with B is not equal to 0, A and B are integers, right? That's how we start, right? What square root 2 plus half is whether rational or irrational. To do that, we start like this, right? Then what do? Tell, please tell. Like otherwise, if you don't engage, then it will not be a good learning. Hmm? Yeah, they so bracket means they're co-prime. So max GCD is one. I mean, like it is 3 by, you should not write 3 by 6. It will be 1 by 2. Write in minimized form. Okay. So that's what GCD means. GCD, that's what the form you should write. So that's why AB is co-prime. That's what I take. Does that make sense? That is okay, right? But how to proceed with this? This is a simple thing. We should, if you can't do, then I'll tell. But yeah, at least you try, no? This is very easy, right? I mean, you do you know whether square root 2 is irrational or rational? So this will be a over b minus half. What you do is 2b, then 2a minus b, right? And when you know b is not equal to 0, so 2b also won't be not equal to 0, and you have 2ab, and a and b are integers, so 2a minus b will be integers, so that will be inside also z. So what you have, 2a minus b over 2b, that is also, that belongs to rational number means square root 2 belongs to rational number that is not true, that is contradiction, right? So that's why square root 2 plus 1. So why it is contradiction? To the fact we started with this, assuming this. This is contradiction to the assumption. This was our assumption, right? Square root 2 uh, plus half, that cannot be rational number, it is irrational number, right? So similarly, with this exact same type of idea, one can also show that 1 plus square root 2 plus square root 3, or that's up that and negative also you can take here, that is also irrational number. You can show that that will be easy. That is also irrational number. So by assuming like a over b, and you do some manipulation to find out whether like, to and use the fact that square root 2 square root 3 this type of numbers are their irrational number. So use those things to prove that uh, their combination or addition, all these things are irrational numbers. So right. Okay, so then it comes to something interesting. So that between any two, okay, this was okay, right, for all of you? If you just confirm it, I'll just move. Okay, good for the responses, and yeah, I'll move to the second whether. See, first one is done. Say whether rational or irrational. This is I write the question's name as density in. I'll tell in which sense, but you have any two rational numbers, then there exists another number. Can you give an example? So let's say A, B are two rational numbers. Any two rational number. Okay, rational number. Uh, Numbers. So can you give me another rational number between these two rational numbers? Let's say you have 0 and 1, they are also rational number. Let's say 0 and half. Can you give me another rational number between 0 to half? Yeah, someone has a nice idea. So just telling that you have a b, you write a plus b by 2, right? So a plus b by 2 will be always inside a and b. If a is strictly less than b, let's assume that, then a plus b by 2. So that is one way to show that, like that will be in the middle, right? And you can you can be sure that this a plus b by 2 is the number which is always between a and b. Now the question will be difficult if I tell you find one irrational number between two rational numbers, right? Or is it straightforward? It's not straightforward, right? So between any two rational numbers you have rational number, that is okay. But what about irrational numbers? So that will come to the next question later in the question. So that is the difficult part. So here question was between, where the question was this, whether between two rational numbers whether there exists another rational number. So that's what we found. So what we can now tell that between any two rational numbers there exists another rational number, right? Rational number. So this was easy part, but this is okay. But The question now you think that whether there exists irrational number between any two rational numbers. That you think I will also you think parallelly. Okay, I that answer I will give. Okay. So yeah, so this part is done. So whether any two rational number, this is where another rational number is there or not. Okay. So the third question or thinking like this, where do the irrational number lie on the number line means state of set of real numbers? Are they really dense? What do you mean by that? I mean, so meaning of that is so any if you have irrational numbers means we denote them by q complement, right? Q complement, which is r minus q. So you have seen between any two uh, rational numbers there are rational numbers, but we don't know about irrational number, where do they lie. So that question will be coming later also. These are the question I want to just give you, and then I tell some theory by doing that, and then I say that how they are like how where they really lie. So mainly what we will so see that between any two real numbers there will be irrational numbers. So, and you have, so if you say, if you can prove that, then you can say that they are almost everywhere in the real number line, right? So if you take any two real number, like let's say you have 0 to 1, there is a irrational number. You take 0 to 1 by 100, then also in between the inside that also there will be another real rational irrational number. And if you consider 0 to like that also, it will be inside that also there will be another irrational number. With any like 10 0.00001 to 0.000 uh, okay, sorry, 2. So there will be also irrational numbers between that. Or if you take 10 also like this, it will be also inside. So any two real number you take in the real line 0. So if you take any two small interval also, there will be irrational number also rational numbers. Okay. So they are, that's why they are almost everywhere in the real line, so that will also come. Okay. Yeah, now it is another very, I felt it is very interesting. You have two real numbers a and b. It's kind of theorem also, you can say it's a and b are equal if and only if every real number epsilon greater than 0. It follows that a minus b is less than epsilon. I'll write the question separately so that you can understand. A equal to b. A, b are real numbers. This all of you should do. If and only if, this is if and only if notation, a minus b modulus of this modulus value of a minus b is less than epsilon for all epsilon greater than 0. This will give you a nice idea about epsilon delta definition later maybe, huh? So I think this is one of the interesting thing. It does not need any uh, like uh, any this or calculus of real variable, that whatever we have read about this number system. I mean, sorry, not number system. The properties of real numbers, all these things we don't need. I mean, we need some basic idea, but that is interesting. Can you take? Can anyone tell me how to do this? How to do this? So you have one way is okay, right? I'm sorry if I right. One way, one way is clear. A equal to B implies A minus B is equal to 0. So that implies A minus B uh, is equal to, that is also 0, and that will be always any epsilon which is greater than 0, that will satisfy for all epsilon greater than 0, right? So this part is not a problem. Everyone is like okay with me? Like, is it okay? Right? So this part is okay, right? This was I mean easy. The toughest one is this one. You have two numbers whose modulus value is less than epsilon, and that epsilon can be any epsilon which is greater than 0. It can be 1000, but it mostly it can be very small number epsilon for all epsilon greater than 0, right? So how do you show that this a minus b is equal to 0 or a is equal to b? Hmm? How to show that? A and b are fixed number, two fixed number, right? So should I wait for people's idea? If you want to give any idea, I'll wait for 1 or 2 minutes. Otherwise, I'll tell you. Because thinking, like you should think also, right? It says that the distance of A and B in real number, it can be, you can make arbitrarily close, because epsilon can be 10 to the power minus 10, it can be 10 to the minus 1000, it can be 10 to the power minus million, like that, right? 10 to the minus 1 million, 10 to the minus 1 million, it kind of can be anything. But how to rigorously say that this is not, this means A and B are equal? Hmm? Okay, so I don't know whether you people are doing, but one way we can say that you have A and B fixed numbers, right? Hmm? Yeah. So you have A and B are fixed numbers. So let's take epsilon naught, one number like which is A minus B, that is greater than 0, right? So epsilon naught is, that's a fixed value because A and B are fixed. Hmm? But for this epsilon naught, what it says that A minus B should be less than epsilon naught, is not it? Because A minus B has to be less than any positive number which is greater than 0. In our case also epsilon naught, which I define like this, which will be A minus B, the value of whatever the value. Let's say you gave me 1 and 2, then I will find out that 1 minus 2, that is 1. So that is epsilon naught, which is greater than, strictly greater than 0. So for that also then this should hold, because that is given to you that A minus B should be less than epsilon for all epsilon which is greater than 0. So here epsilon naught is also greater than 0. So it should be less than epsilon naught. But this is contradicting the fact that A minus B is again epsilon naught, and this one is it is telling less than epsilon naught. So this is kind of contradiction. So it cannot be this uh, if A is not equal to B, if epsilon naught. So assuming that if it is strictly greater than 0, right? So that for that it has to be A has to be not equal to B. We start with A not equal to B, sorry. So start with A not equal to B, then epsilon naught will be A minus B, which is greater than 0, right? So then what you will obtain? So you will obtain this contradiction. So if you start with anything other than A not equal to B, you will not have this contradiction, because A epsilon naught, you will not have is strictly greater than 0. Hmm? So it has to be happen that A is equal to B. So anyone, if you don't understand, please tell me. If you are not understanding, where exactly? Okay, if I ask like a Sandeep theory, right? Someone is there who was telling something by sequence 1 over n and all. Can you please explain? That will be better for all of us. Huh? I'm not. I mean, I'm not scolding you or something. I mean, you just tell me that whatever you want to tell. 1 by n sequence or something. Right, if your microphone is not working, you can also put in the uh, message box, right there also you can, so we can have different idea for solving this, right? Okay, you put in the the message sorry, message box. That's also okay. But what you want to say, I just want to know, and I want to let people know if that is correct. Also, if it's better than this, or it may not be better than this. It can be alternative, right? So that idea also one can take. Okay, I think he's talking about 1 by n sequence on all and all. So, see, Sandeep, I don't want to go by through that sequence idea now because sequence is not done. See, 1 by n is converging to 0. How do you show that? That is first question, right? So, 1 by n, that's what, if I'm not correct, if I'm not wrong, then you are using the idea that 1 by n sequence is converging to 0, right? Yeah, so your idea will be taken once the whole course is done. I think, I don't know if sequence is there. Otherwise, this idea you should not take because everyone will not understand. So, but yeah, this is the thing which I did. I think most of the people will understand, and if not, please let me know. So, there's something very easy and very interesting also at the same time, right? Okay, everyone else understood, right? Hopefully, that how this a minus b is less than epsilon. Okay, so I'll move to the next part of the lecture, which will be one of the most important. So first, this which is called Archimedean property. So this I felt this also you should know. Then you can solve many other problems also. So this is mostly the problem solving class, right? So but yeah, few things I wanted to add, like this one. This is like Archimedean property, which will be very useful for you. So you just remember this one, this as a theorem maybe. If x and y are two real numbers and x is greater than 0, y is greater than 0, then there exists natural number which will make ny greater than x. So if you know these, then you can prove like many problem. This is Archimedean property. It's called Archimedean property. So, with using this Archimedean property, what else you can show that as a like corollary or something? This you can show that. You can, so the density of rational number, density of irrational numbers, which I started asking you questions, that you can prove, right? So what Archimedean property says, you have x, y are positive numbers. I think even if x is not positive also, that will be okay. So let's forget that. So ny or nx, ny will be less greater than x. There exists natural number n belongs to, I mean, there is a natural number n such that ny greater than x. So by that, what you can show that these natural numbers, set of all natural numbers, they are not bounded, that you can see from here. Because if you start taking 1 and let's say x, hmm, two numbers, real numbers, instead of x and y, uh, so x and 1, like it take in order, so it will be okay. So x and 1, two real numbers. Then if you use the Archimedean property, what will have, n times 1, which will be greater than x, right? So n will be greater than x. So if you have any real number x, then there exists a natural number such that that will be, natural number will be always greater than that real number. So if you take any big real numbers, so even you will have one natural number which will be bigger than that. So what does that imply? That implies these natural number sets are not bounded, right? If you take any x, which is any x, you just take very bigger, then there will be another, say another natural number which will be bigger than x. So that is some simple from just as a corollary of this Archimedean property. But what else you can prove? The first one, we'll move to this question 6. You have, let's say, 0 less than equal to a less than 1 by n for all n. Hmm? Then a is equal to 0, nothing but a is real number. You start, a is real number. Can you just, I told you what is Archimedean property, right? Can you just quickly use it and can you do this whether a is equal to 0 or not? Yeah, Sandeep, if it is easy, please do it without using the idea. If you were telling 1 by n is conversing to 0, that idea you should not use here. Without that, please do it. Yeah, if you can do it, that is good, but without that idea, okay? Others also, everyone, please do this, try this. I am just telling you that only you have to use Archimedean property here. So what is the Archimedean property? You have two real numbers, any two real numbers, x, y, then you have, there will exist a natural number which will make ny, n times y multiplication is greater than x. Just use that to prove whether a is equal to 0 or not. Hello. This is easy, right? How to show that? So if you start with A, which is, let's say A is not zero. Let's say A is not zero. Hmm? What you can show that? You consider 1 and A. Let's say A and 1, two numbers. So there exists natural number, n belongs to natural number, such that n times A is greater than 1, right? That is only possible, you see, if A is not equal to 0. This you have to realize. So A is not equal to 0. Only because of that you can write n times A is greater than 1, right? And that implies, so there exists n. Let's say I will keep that n as n naught to specify what is like exact that n naught. So that's n naught, let's say. Hmm? So n naught times A is strictly greater than 1. That implies A has to be strictly greater than 1 by n naught. Hmm? Right? So A is strictly greater than n naught. But what it has to be that A should be less than 1 by n naught for all, because it has to be, as A has to be less than 1 by n for all n. So this is what the contradiction. That's all. I think that is done. You check it now. Now on you whether you understand this. Then I will say, if you are not understanding, then I will tell again. If someone get it, then they will get now itself. It's done. That's it all. That's all. Yeah, Sandeep is okay, right? And all others, everyone. Yeah. Okay. So if you have understood that, I think you will feel the uh, interesting part of this talk. I think yeah, one of the interesting part of the talk is this. So this question, and before that you had modulus of a minus b is less than epsilon for all epsilon. Then you show that a minus b is nothing but a and b are equal, and here you show that a is less than equal to n for all n natural numbers, and a is also greater than equal to 0, then you would show that this is nothing but a is nothing but 0 only. It can only be a 0, it cannot be anything else. That's all. So okay, so with this, so what you can show that even you have a minus b, which is, it is always greater than equal to 0, right? So you don't need to say anything. So a minus b is less than n, then you can show that a is equal to b if it's for all n, right? It follows from there, because a minus b will be equal to 0 in that case. A minus b modulus is equal to 0, and a minus b modulus will be 0 only when modulus of a is equal to b, because of their real numbers and all. Right? So that is also will be true. So what we have show that if this is happen, then also E is equal to B, or what you have a minus b is less than epsilon for all epsilon greater than 0, then also it will be equal to b. So these are the thing you will be using like whole throughout your life if you are taking uh, mathematics course. That's the basic idea. So if you don't understand, please tell me. Then I will proceed to the next question, which is question 7. You can also have a look at it, and before that, I will be waiting for people if they did not understand. And others, please read the question 7. Okay, something I made mistake here in the question, but I wrote and discussed is those are okay. So this will not be proved that this part will not be there. So everything else okay. So whatever I proved and I said those were okay. Some extra typo was there. I just removed it. I'll save it and I will send it to you, all of you. I will put it in the Google Drive and you can check it. All these things. These notes will be shared. Okay. So please go to question 7. I think question 7 is very easy. So I may leave it to maybe also just you can do it. Okay, so this is also very easy. So you have this question here itself. I'll write the answer. So you take 1 and y, and you have there exists a natural number. Let's say that is here. I'll call it as m itself. Let's say then m times uh, y will be greater than 1. Y is always 0, so that so that implies y will be greater than 1 by m, or you can always 2 to the power m is greater than m, right? So 1 by m will be then, no, sorry, uh yeah, I mean, instead of m you start with this, there is just a natural number, right? So 2 to the power, sorry, yeah, 1 by m. Yeah, I think I was correct. No problem, right? So from here, what you say that 1 by m should be greater than 1 by 2m, right? To the power m. Hmm? Correct. So 1 by m then is less than greater than 1 by 2 to the power m. So from here, what you can say that y then it has to be 1 over 2 to the power m. And 1 by 2 to the power m is positive. So that's how we prove this one. Is it okay? I can't hear anyone. If someone trying to speak, I'll just move to another device to check your message. Okay. Okay. So Aditya is telling he understood. Yeah. I hope all other also you understand, because I did we did many questions on this Archimedean property. So this was one of the easiest one we are doing here. So that I hope you will understand. Okay, so if so, we'll move to the, yeah, that I say one of the central part of the talk. Okay, this is the density of real rational numbers and density of irrational numbers. So between here it says that between any two real number you can find rational number, you can find irrational number also. That is denoting by R and denoting by S, and both of, to prove both of these, we'll use only this Archimedean property. So that is why Archimedean property is that much, uh, what you can say, that much powerful, right? So density of rational number first we'll prove, and we'll show that also how density of irrational numbers are also dense in real number line. I mean, if you just close your eyes and touch somewhere in the real number, you can find both rational and irrational number. That type of, I mean, they are dense in real number line. So density definition, yeah, I don't know if you have read some book. So someone in it was given like interpretation like you have a pond, and how do you say that fishes are dense in that pond? Hmm. How do you show that? If you have any small net, you know, right, to catch the fishes. So if you have any small net, then you can, if you throw that net with even very smaller net, you can find the fish. You can catch the fish. That is the that's that's how mathematically precise the definition is, that it has to be that much, like density means that. So anywhere in the water with any small number of, like small net you throw, then you will find the fish. The fishes are dense, and then only fishes are dense in water or that pond. So here also the density is like this. So you take any two real numbers, you have in between you have your rational number and irrational numbers. Okay, so yeah, so what we had proved that if what it was easy for us, if we had two rational numbers, we could find that, we could tell that between in between that there is a rational number, because that you take just a plus b over 2. You have a, which is rational number, you have b, which is rational number, you just take average, you get another rational number. That will be always true. But let's say you have one rational number and one irrational number, then you cannot do that thing, right? A plus b by 2, and you will not always, you cannot guarantee that that will be rational number. And you can have also both irrational numbers. So can you say that in between that also there is rational number, right? If the question 8 says that in all those cases you will get rational number, how to show that? So that's not an easy task. That is one of the question I want to solve. This density of rational number. Anyone want to say something about this? Okay. So if not, I will move to proving this. It will be easy. Just we will be using. Uh, few property of this Archimedean property. Few Archimedean property mainly will be using. So you have x, y, any two real numbers. You have to find a rational number between them, right? Let's also we will be assuming that x is less than y without loss of generality, right? We can assume one of them, either x is less than y or y is less than x. And yeah, also you assume that x is not equal to y, because otherwise you cannot find there's a one number it will be. So they assume that they are distinct at least. So and assume that one of the, like either x is less than y or y is less than x, like that. Is that okay? Hmm? Right? So if you have that, so if it's not okay, then you tell, okay, please unmute yourself or put in the message, I will go and check. Then you have y minus x is greater than 0. If you have y is x is less than y, then y minus x is positive number. Okay, once you have positive number, you can now use this Archimedean property with y minus x, sorry, y minus x 1 and y minus x. You put use Archimedean property on this, then what you will have, n times y minus x, right? Because y minus x positive, that is greater than 1. That implies y minus x is greater than 1 by n, and that implies uh, yeah, so don't need to do that. So we'll what we will do that n times y minus x is greater than 1 implies, I'll do it in this way, n x plus 1 will be less than n y, right? So you have nx plus 1 that is less than ny. Okay, so that keep in mind. Also, what you can show that for any real number, you have natural numbers. So if you want that proof, also I can give later. But for now, you just assume this. Nx is a real number, right? So for that real number, you always have a natural number m belongs to n. So it's a natural number such that this whole. There's also you can interpret it like if let's say you have 3.5, let's say, then you have, you can say that 4 is the m, right? 3.5, if it is 3.5, it will be between 4 and 4 minus 1. It is 10.2, it will be between 10 and 9, right? Sorry, 11 and 10, right? 10 and 11. So you can it is also easy consequence of the Archimedean property. I can also prove that if you want. Otherwise, you assume this for now. Okay, but it will always be true. You can have the interpretation also that yeah, it will be uh, it will always, there will always exist a natural number m such that this holds. So once you have this, right? So you have m minus 1 is less than equal to nx less than equal to m. That implies nx plus 1 is greater than equal to m. What do we have? Nx plus 1 greater than equal to m is, it is, I mean, greater than equal to m and less than, strictly less than ny, right? This is from these two. Let's say I write it. This is 1, this is 2, this is 3. So 1 and 3 implies this. 1 and 3 implies this one. Okay. So also what we have? So uh, we have nx, which is less than equal to m from 2. from 2. We have nx less than equal to m. So this 4 and 5, with this what we will have, 4 and 5 implies nx less than equal to m less than, sorry, strictly less than, I think nx was also strictly less than m. Okay, that's okay. Strictly less than equal to m and strictly less than ny. Right? So this one of the inequalities. So in the second one, this will be strictly strictly less than. So this will be there. So strictly less than. So this is also strictly less than. So this implies x less than m by n less than y. Did you get what we wanted? Did we get what we wanted? See, everything lies in this base only. We start with y minus x and 1 as the Archimedean property says, and we do some calculation to prove that there exist real number, there exist a rational number which is of the form m by n. M and n are natural numbers, so m by n will be always integer, rational number, and that is belongs to x and y, and where x and y we started with any real number, right? So that much beautiful this is. So what you can do at your home, that you take any two real number, let's say square root 2 and square root 3. So you try to find a real number, a rational number between that square root 2 and square root 3. See, between 2 and 3 it will be easy. 2 plus 3 by 2. But between 2 and square root 2, or square root 2 and square root 3, yeah, and this possibility, this type of possibility, with this type of possibility, it is not just, you cannot do by just taking average. So for that you try to use this theorem and find the real exact natural numbers, and you can say that you can find then what is the m by n which lies in x and y, between x and y. Is this okay? So only assumption we had here is, it's not assumption, that I can also prove that later or some now. So this is this part. So you assume this part, and then you, yeah, so all other things. So this, we started with x, y, and e to real numbers. We moved to the fact that there exist rational numbers. So because this is nothing but rational number, right? Okay. This is rational number, because you have our m and n are natural numbers. Did you get it? This one? Okay, is it? It uses just the Archimedean property, nothing else. So can you do the other one? I mean, between any two real numbers, there is rational numbers. Okay, one of the homework is you find out m and n by fixing one x and y. Okay, that x and y should not be your, for this case, should not be your rational numbers. Mostly they should be both, at least either both are irrational numbers, or one of them should be irrational number. Okay, then difficulty will come. So that's why take that and try to find m and n by like using this procedure, and then you will understand better. You can also find out the what is the rational number between that. That is one thing. And now you prove that, you try that whether between two real numbers, whether there exist irrational number also. Okay, I'm not speaking. Okay, I'm asking you. So someone Aditya, I think, asked something. Can you just turn on your microphone and just tell what you are asking?
Hello, sir. Can you hear me?
Yes, yeah, I can hear you.
Sir, for like the previous proof, for like the second equation, you just assume it to be between two successive natural numbers, right? And then you can like,
But that is not natural number. That's what you are asking. That between two successive natural number, there cannot be any natural number, another natural number, right? So, but
no, no,
here,
no,
yeah,
no, for this second step.
yes, between any two, if you have any real number, you have two successive natural numbers. Between that two successive natural number, there will be this real number.
Oh,
Yeah,
okay,
but this, yeah, it is. That's what I said. It is easy to interpret it, but can you prove it? So that proof is also it can come from the Archimedean property. If you want that, I can give. But otherwise also it will be true. Always true. That is the answer.
okay, sir, understood.
Yeah, yeah, yeah. Okay, okay. So anyone else, if you have any doubt? Okay, so think about the irrational number one. How to show that is irrational number? Can anyone come up with some idea which will be unique? Huh? Okay, so if you are not getting, then only I will. So you have tried, right? Then I think it's my time to give you the answer, maybe. Okay, so let's forget that like we have what till now what do we have in between any two real numbers you have rational numbers, right? Between any two real number you can find out rational number. Okay, yeah. So from here, okay, let's move. Then I will tell that. So and tell something more about this also. Okay, but before that, okay, let me change the color. Okay, so you have like x y. You start with the x y. Let's start with square root to x and square root to y, right? So then what we'll have? You can show that square root to x, they are two real numbers. So between these two real number, you will have another rational number. Let's say r, or it will be like of the m by n form, some m by n form, square root to y, right? Is this okay? Because we proved it in the previous question. That implies x less than uh, m over square root to n is less than y, and m by n belongs to rational number, and but if you multiply square root 2, that will not be belongs to set of rational numbers, so that will be set of irrational numbers. So you have irrational number between any two real numbers. So start with xy and then take square root 2x and square root 2y. They will be real numbers, and between that two real number we have proved that there is a irrational number, sorry, rational number. And now if you divide by square root 2, that m by n square root to n, that will be irrational number, and you have irrational number between x and y. Is this okay? Was this much easy or something like this? So this I thought you will understand. And instead of square root 2, you start with square root 3 also. Those are not a problem. But this is what the thing. So can you tell something more about this? So you have real number line. You have, let's say, A and B, and you can say that between A and B there is a rational number, right? What is that? Let's say that is C. Rational number. Take A and C. They are also, C is rational number means C is real number also. So between A and C, will there be rational number again? There will be again rational number, because any between any rational number there is a rational number. So that is D. So that D will be also belongs to. So first A and B, you had A and B. So inside that C is in A and B, that interval. We denote that interval like this. But again you saw between A and C there is D, which is rational number, which will be belongs to A and C. That interval means A and B. So D also will be inside A and B. So again between A and D are real numbers. Between there will be E. So keep on going, keep on going. So what we will have? We will have infinitely many irrational numbers between any two real numbers. Similarly, we will have infinitely many irrational numbers between any two real numbers. Is this also okay? That's a consequence of, just if you can prove between any two real numbers there exist a rational number, also there exists irrational number, then you can just prove that between any two real numbers there are infinitely many rational and irrational numbers. Correct? Did you understand this? Any doubt, please tell. I'll just check your message also. Just put in the message also, then it's also no problem.
Clear.
Yeah, anyone telling anything? Want to say something?
Clear.
Yeah, tell.
Sir, it is clear.
Okay, clear. Yeah, that's okay. Okay. So what we got that I'll write it here. So hope you all will agree because we have proved between any two real numbers there exist infinitely many rational and irrational numbers. Hope you understand here that that the conclusion I wanted to make from. I mean, I'll say that this is one of the central part of the talk. Sorry, the not talk, the tutorial session. So between any two real numbers, you have infinitely many rational and irrational numbers. So whatever number you choose, that you will have that infinitely many rational and irrational numbers. Okay. So till now, if you have any doubt, please tell. For from like from first to up to this, it's clear, right? I'll make this interactive session much more interesting from maybe the next class because this time I did not get much time to prepare for the lecture or for the tutorial session. But yeah, we'll make the next classes much more interesting. Okay, I hope these are the some interesting questions I could find, but yeah, it was not all the questions were interesting. You Yeah, I'll tell if you have any questions, you personally mail me, send a message or something that put in the question answering session that something is there for you people I forgot there put. I'll reply or I'll try to solve those things also. If those are interesting, I can put it here also, I can solve here also. Okay, so it needs some interesting questions to get interest because you people are starting the things, right? So may I know whether you people are from math background or started math in BSc or something? You're doing BSc, right? Or you will be doing BSc like that? Hmm?
Sir, I am preparing for CSIR.
Sorry, you are preparing for CSIR,
Yes, sir.
but you are BSc, right? You started preparing for CSIR. Priyanshu Rajan, I'll share with you, like with all of you, the Gmail. So, Rahuldev 19 at the okay. Let me write it. If you people, some people may leave. So okay, this was I forgot to delete this books and this should not do. I will make it. So but the mail is so it is my name and then my batch and then at the rate my institute and then this. Hope it is you can understand. Okay, I mean ignore the bad handwriting. Try to find out what I have written. Rahul Dev is my name. Then 19. Then at the rate my institute name is a tvm.se.in. Okay, if you can reach out here, you can anytime you can send mail. You can I'll try to reply. Okay, otherwise also you have some panel session question answers there also you can put it. Okay, anything I have no problem. If you want to create some WhatsApp group or something there also not a problem. Let's learn and yeah, we'll have a nice session from next classes. Okay, this class is not done anyway. I'll share this PDF, so there you will have this mail ID also. Okay. Okay. Let's come back to our usual thing. What is left with? Okay. So any doubt till now? No problem, right? Okay. We have last few questions for to solve. Then we'll end today's session. Most of the interesting parts are, I think, gone. But yeah, still you have something called Cantor's theory. We have said, and you said, you cannot have any onto map or surjective map from A to the PA is calligraphy PA is subset of A. All the subset collection of all the subsets of A is PA. You cannot have bijection between this. So that is the theorem, and the proof is here. So tell me whether you understand or I need to explain it. Where you don't understand. I just wrote the proof in case like this is little like it is a construction, nothing else. So this is something beautiful theory. I mean, you have a set, and from a set, I mean, the number of elements in the like in the collection of all the subsets will be bigger than the number of elements in the set. That's what this map says, because they're not onto. There's many more elements are there in the subset. Sorry, in the collection of subsets. Here A is any set. So start with the contradiction. So that's like let's assume that A to PA is onto map. Let's say if you have onto map, then what is the meaning of this onto map? Onto map means, so let's write maybe here you have, let's say F from A to PA is onto. This is assumption, let's say. Then what will have? If you have any element here, that will have a corresponding here. I mean, you have, if let's say you have something, some set, so that will be coming from F of A. So all the sets here should look like F of A. That is the meaning of onto, right? The meaning of onto is you have S, then there will exist A. You have T, S, T, why I am telling they are subset of A, so they are element of this, so then there will exist B, something like that. So I mean, all the elements of PA, if the map is onto, will look like FA such that A belongs to A, right? If this is true because we assume that F is onto function, right? Now we'll construct a set B. How? A belongs to A such that A does not belongs to F of A. Right? So B is the set which is the subset of A and which has all those elements. If those elements are not in the set which is mapping to that set, because each element of the set A is mapping to another set of another subset of A, right? We are assuming that that element is not in that subset. So you can ask that B can be phi, so it can be phi also. That's not a problem because B cannot have anything, so that also it can have. So once you have B, B is the subset. B is the subset of A. But you cannot write f of any element is equal to b, right? Because if you have, let's say there exists b such that f of b is equal to b, let's say if you have, then what will have, f of b is the set that is nothing but a belongs to a such that a not belongs to f of a. That type of set is it, right? So if you have this, which is b, so and f of b is equal to b, so it cannot have this b, all those elements which are in b, means b belongs to that a such that fb will be equal to b. That's what this means, right? So if you have b is a set such that this happens, then it cannot have this b which has to belongs to f of b, right? Because b, you are starting from capital B, so b should be belongs to f of b, but b does not, from here does not belongs to f of b, because that is the definition, right? I think I have written it here. Do you understand this? Just want to know whether you got confused. So I was confused actually. So you have, for a b which is in pa, we found a b here such that b is mapping to f of b, which is equal to nothing but b, capital B. So that implies b should not belong to f of b. Sorry, b should belongs to f of b. But that is not happening here, because construction of b is like that, ki a is not that it should not belong to f of a, right? Is this correct? Do you understand this? I mean, I'm a little bit still confused, but I am not understanding whether you people got it. If not, we can discuss the next class also. There is not a problem. But do you understand this? Hello. Okay, okay, I'll check the message if you are. I don't find any message also. People are not responding. See, if it's not okay, you can tell. Not a problem. So then I'll understand. Otherwise, I'll proceed. I think you did not understand. So just want to just confirm that you did not understand. See, for each element A, okay, let me put it maybe little more way here. So for each element A, it consider the subset FA, because FA is now monomer, like is element, it's a subset of A. So this subset FA, which may or may not contain A, right? So it's first of all, it depends on the function. If FA does not contains A, if A is not in FA, then A we will consider that in B. So that's how our B works. If all those A we are considering such that A does not belongs to F of A, then only this will be B set. Now if B set, I'm telling that B set cannot be some F of B for some B belongs to A, right? Okay, so what is your B? So B has all those A which are not in F of A, right? So this B, if it is not in F of B, if it is not in F of B, then B belongs to B. But F of B and B are equal, so that cannot be, right? If B is not belongs to F of B, then B belongs to B, capital B. So that is contradiction because B is equal to F of B. And if B belongs to F of B, then the definition says that B cannot belongs to capital B, because B's definition is this, right? B is the function, B is the map defined like this. B is the map. Okay, let's write it here. B is the map defined like all those A belongs to A such that A belongs to F of A. Sorry, it does not belongs to F of A. So if B belongs to F of B and B also in A, right? So B belongs to F of B, then this definition says that B cannot belongs to B, capital B. But that cannot be, because F of B is equal to F of B. That is the assumption we started with. So this B is equal to F of B assumption is contradiction. So B cannot be F of B for some B. So when this cannot happen, then if you are taking from F from A to F of A, sorry, P of A, and you find a function, find a B in PA, which is subset of A, but B is not in the any form of F of B for some B belongs to A. So this function cannot be onto. Is this now clear? I hope, like, because from my side also clear. So hopefully it is clear now, right? You construct a B such that, so B definition, let me put it here also that it will be much more easier. If such that A not belongs to F of A. Yes, those are the elements which are not in F of A. Is it okay? Yeah, I think it is once you just go through it. So instead of first this one, don't do this page one. So this page one will confuse you. So start with this one. So this is correct. So start with, you have like on to function. Let's say on to, you have function, and you have A which will go to then F of A, which will be a subset. Now F of A is a subset, so A can be belongs to that subset, or it cannot be, it may or may not belong to that subset. We consider we consider the subset of A, capital cap A, by constructing like this all those elements which are inside cap A but not in f of A, because f of A is also subset. So then we show that whether B, this cap B is of the form any of f of B, some B. If that is so, then it is onto that, we cannot say anything. But if you can disprove that this B is not any in form of any f of B, f of small b or something, f of C or something, then it is not onto, right? So that's what we showed that here, right? Any doubt here? Yeah, okay, if not, we'll move to this one, question 9. Evaluate the limit. So square root of 1 plus x plus 1 or minus 1 over x tends to 0. So we come to the last part of the lecture, tutorial session, is limit x tends to 0. Just I wanted to cover a few things, so that's why it will not be continuation of whatever we are doing, but it is like all the topics are covered. So that, so square root of 1 plus x minus 1 over x. How to do that? I mean, how to do this? What to do for this one? Anyone up for it? So what we do usually, 1 plus x minus 1, as this is the end of the class, I don't want to make you guys sitting still, so I just do it. It's easy, but most of the important parts are already done, so don't need to worry about these things. X times square root of 1 plus x plus 1, and then what will happen, this is a plus b and a minus b form, so square root of 1 plus x square minus 1 square over x times square root of 1 plus x plus 1, and that gives you nothing but 1 plus x minus 1 over x times square root of 1 plus x plus 1, that is nothing but 1, sorry, x over x, so x will go vanish, so then square root of 1 plus x plus 1. Mainly if you want to evaluate the limit, so limit x tends to 0, and then square root of 1 plus x minus 1 over x will be nothing but limit of x tends to 0, 1 over square root of 1 plus x plus 1, and that is nothing but is not singularity, and nothing is there, so now no problem, no blow off, nothing. So you just put the value and you will get 1 plus 0 plus 1, that's nothing but half, right? Okay, so then the last problem is, so what is the problem? So this is done. So then question 10, 1 minus cos 2t over t. This was in your assignment, I think. Question 10, limit t tends to 0, 1 minus cos 2t over t, I guess. Cos 2t, cos 2t over t. Yeah, t tends to 0. This is the last problem we'll do and then leave it. So first I let you try and then I'll do it. Yeah, what to do this for this one? So what we do is we can say always this 1 minus cos 2t. I think it will be 1 minus, what is cos 2t? Cos square t minus sine square t, and then you have so it will be 2 sine square t. Yeah, so 2 sine square t, and if you take a limit as t tends to 0 and put this evaluation, so this will be 2 times, sorry, let's put it it's 2 sine square t over t. So that will be nothing but limit t tends to 0 and you take 2 outside, then it will be sine square t, but I take it sine t, right, over t times sine t. Now it will be 2 times limit. You can always take limit in this like multiplication, and then you take it limit, because these two all both the limits are I mean limit exists, I mean bounded function, and one means once limit exists, so you can do all these things here. So it will be multiplication with sine t, right, and so that will be equal to 2 times limit as t tends to 0 sine t over t is 1, so that you can see, and limit as t tends to 0 sine t is 0, so that's why it will be 0. So what we have used, so use the fact that limit as t tends to 0 sine t over t will be equal to 1, and limit that is always all of us know, so sine t is equal to 0. So we have used this two fact to show that this happens. Sorry. Okay. I think that's all for today's class. If you have any doubt, please ask me. Otherwise, I'll stop for some time. Maybe 2-3 minutes. I'll stop. Okay. Okay. Kailash, I think asking something. Zero or something. I did not understand what when you asked. Can you please elaborate it? What you asking? Kailash. At this message, okay. All other can you can leave for today. Again, in the next week we'll have Saturday. I'll come up with some more interesting thing to make this uh, tutorial session much more interesting. Okay. Yeah, but Kailas, you want to ask? You are asking something, right? You ask something zero or something. Okay, okay. You were just confirming that whether its answer is zero. Okay, okay, no problem. Yeah, okay, we can leave. Okay. Thank you, everyone. See you in the next week in this around same time. Okay, not around some exactly at 7 o'clock. Saturday. Okay. See you. Welcome, Priyanshu. Yeah.